All right. When you have two equations and you're solving a system of equations, what you're doing is finding out where those two equations intersect on a graph. And there's three ways for it to happen. I'm going to draw three little graphs over here. Either they intersect at one point, like right there would be the solution, or they don't intersect at all, they're parallel. That means there's no solution because they're never going to intersect as long as the day is long, right? And there's the other kind where it looks like a line on top of a line. They're really the same line in a different way, they're expressed in a different way. And that one would have infinitely many solutions. And we will do a couple of those, of each of these, so you know what they look like, okay? All right, but this one here is going to have a solution, I think, from what I can see. And we've got to figure out how to solve this by elimination. Elimination says it all in the word. You got to eliminate one of the two letters. By the way, if the letters in the equation are not x and y, you put them in alphabetical order, and your first one would be your x and your second one would be your y. If you want to rewrite it with x and y's, go for it. There's a couple of these that might have p's and q's and d's and b's, and if you have problems with that, rewrite them so you don't have that issue, okay? But you put them in alphabetical order, and that'll give you your x and your y to see where they intersect. Okay, so here the r would be the x, and the t would be the y, because r comes before t in the alphabet. Everybody get that? So first thing you're going to do is figure out a way to eliminate one of the letters. And in order to eliminate one of the letters, they have to be opposites of each other. That's the first thing we're going to do, is find a way to make the t's opposite of each other or the r's opposite of each other. Now, there's not a right or wrong answer, but there might be one that's a little bit more difficult than the other to do. In this case, the two t's are positive. What can I do to one of those equations to make one of those negative? If we multiply one of these equations by -1, we'll have the first equation the way we saw it first, which is not a big deal. The second one, we're going to change all the signs. Now, if I add these two equations together, the t's bite the dust. And I have r, because 2r minus 1r is r, equals 1. Look, I already found one of my guys. I found r. So, we have r, we need t. The second step is always the same. You plug it into one of the original equations. Not the one you found, but the one of the original. So I'm going to pick the easy one, which is -r plus t equals 5. So that's going to be -1 plus t equals 5, and add 1 to both sides, and t equals 6. And then I do a little check. When I plug in r equals 1 and t equals 6, does it add up to 4? What is -2 times 1? What's -2 times 1?
-2.
-2 plus 6 is 4, so that works too. You see how the second equation works? So what we can say is that this graph is going to intersect at 1, 6, because the 1 is the x and the 6 is the y. So it's going to be, if you drew the graph, it's going to intersect right up here somewhere, okay, where this is the 6 and this is the 1. Okay, so now we're going to look for two letters that we need to make opposites of each other. But look at the p's. Aren't they already opposites of each other?
Yes.
Yeah, so I can just add those two equations together.
So are the r's.
Oh my gosh, so the p's bite the dust, the r's bite the dust, and those bite the dust. So we get 0 equals 0.
That means parallel?
No.
No solution.
So, if this gives you, if all your letters eliminate, and it gives you a true statement, it is infinitely many. Is 0 equal to 0?
Yes.
Yes. So that gave you a true statement. So it's infinitely many. These two lines are the same line. If you were to graph them, they would be on top of each other, okay?
So anytime it leaves.
I'm going to do this one. I'm going to do the same problem. But on the bottom, I'm going to put -2p plus 3r equals 8. Okay? And here, the p's eliminate, the r's eliminate. We get 0 equals 14. Is that a true statement?
No.
So this one is going to be no solution because it gives you a false statement when all the letters are eliminated. So when you eliminate all letters, you have to see if it's true or false, and that'll determine whether it's infinitely many or no solution.